Welcome to today's Postgres World webinar, Apache Cloudberry Incubating, the latest database for SQL at scale. We're joined by a fantastic roster of speakers, including Jack Eistock, CEO of Infuse.io, Ed Espino, database development veteran, and Louis Magnano, owner and engineer of Magnano Data Consulting. Welcome. Together, they're going to discuss how Apache Cloudberry complements PostgreSQL to optimize performance. They're going to discuss real-world use cases for big data analytics and show some hands-on demos to showcase fast and scalable queries over massive data sets. My name's Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. And I think that's all I got. So take it away, Jacques.
Thank you, Lindsay. So welcome, everyone. I'm super thrilled to see how many people signed up to watch this webinar. And I'll be kicking things off for the next few minutes just to sort of set the stage for this groundbreaking announcement into the Apache Foundation ecosystem that Cloudberry has just done. I've been bestowed this privilege because of my over 15-year history working with the massively parallel Postgres-based system called Greenplum Database. And today, we're here to talk about Apache Cloudberry, also a massively parallel database system, but representing a major leap forward, specifically really in open source innovation. I'm joined by several of my esteemed colleagues who've literally been instrumental in shaping this project and who many of you in the audience will probably recognize very quickly from either the Postgres community or the Greenplum communities. That's both Ed and Louis. We also have a couple folks in the background here to provide answers to your questions along the way. And if anybody has ever met me or talked to me before, you know that I much prefer a conversation. And so please use that chat window, type in your questions. Let's make sure that this is informational and educational for everyone who watches it. So together, in the next 45 minutes, we're going to walk you through the story of Cloudberry, why it's needed now more than ever, how it works, and what makes it such a powerful solution. To give you some context, let's start at the beginning. The relational database landscape owes a ton to Postgres. And over the last 30 plus years, the Postgres community has built an incredible piece of backend technology that's trusted by developers, enterprises, and researchers around the globe. But as the demands on data systems grew, other organizations saw the opportunity to extend the foundation that Postgres laid. And back in 2003, Greenplum emerged as one of those pioneers, creating a massively parallel implementation of Postgres. Now, what does that mean? It really means instead of a single Postgres database, Greenplum allows hundreds, if not thousands, of Postgres databases to work together seamlessly. It brings unprecedented scalability, and it enables queries to span massive data sets while still keeping all of that complexity hidden from your end user. Now, if you're thinking to yourself, what the heck did he just say? Don't worry, it can be a little confusing, but I know Louis is going to explain it better in just a little bit of time. From the success that Greenplum had in those early days, that success caught the eye of EMC. Many of you guys may have heard of that organization, EMC, who acquired Greenplum back in 2010 to compete against data giants like Oracle Exadata and Teradata, and later even Hadoop. Now, as time went on, EMC became part of the Dell family, and hence you've certainly heard of Dell EMC. And there, Greenplum's technology continued to evolve, even as some of these cloud players that you've heard about today, like Amazon RedShift, Snowflake, etc., even as they entered into the picture. Now, in 2015, Greenplum was brought to market under the Pivotal software umbrella, part of the Dell EMC family. where at Pivotal, we held deep-seated beliefs, and this is where Greenplum took a bold step forward. We open sourced the code. So after over a decade of development internally, creating this machinery, we took that bold step to give it to the world. And by doing so, I believe we aligned ourselves with the Postgres community's commitment to accessibility and innovation. However, as Pivotal underneath VMware, as time went on, VMware acquired Pivotal software. As VMware transitioned underneath the Broadcom umbrella, because VMware has just been acquired, the passion for open source that drove all of these efforts really began to wane. And now, unfortunately, we find ourselves in this spot where Greenplum itself is no longer open source and available to the community. So what happens? We enter in Apache Cloudberry. So today is really the formal launch point and announcement of this next chapter. Apache Cloudberry, the open source, massively parallel database system, really geared towards next generation data warehousing and analytics. Cloudberry really builds on the fundamental and foundational ideas that Greenplum created, but with a renewed commitment to open source principles and modern scalability. This is a project that's born out of the community for the community and aims squarely at meeting the evolving needs of enterprises and users, researchers, handling massive scale workloads. So with that, I'm going to stop talking and let us get into the actual information. I'm going to pass the mic over to my colleague, Ed, who's going to dive deeper into what makes Cloudberry special, why it's critical for organizations today, and the technical innovations that make it all possible. So Ed, take it away.
Thanks, Jacques. Appreciate that. It's great to be here. Thank you all for joining us today. We're going to be exploring why Apache Cloudberry could be the change your data strategy needs. I've been involved with open source communities and DevOps for some time now. I grew up with this in this industry. I live in the San Francisco Bay Area, and it's just been an amazing career. And it's pretty cool how it kind of continues here with something really exciting for me. In the world of tech, where things evolve rapidly, finding the right balance of stability and innovation is critical, as you might understand. And sometimes change, just the right kind, is what people, what propels us forward, people and the technology. Cloudberry embodies that shift, bringing fresh solutions while staying rooted in proven foundations. Next. And so let's take a quick journey back. In 2015, Greenplum opened up to the community, as Jacques mentioned, almost like a shared garden where users and developers could contribute and nurture something really special. For nearly a decade, it grew with people from all over adding their insights and improvements. And I was part of that journey, and it was just really exciting time. But then a decision was made. Put up a fence, take Greenplum to closed source. Honestly, from my perspective, I have no hard feelings in the decisions that were made. Business is business. Thankfully, we've got a new space to cultivate together with Cloudberry, a fresh open garden where collaboration can thrive again. Next. Cloudberry is now in the Apache Incubator, officially being nurtured within the Apache Software Foundation, the gold standard in open source software development and governance. Think of Cloudberry as Greenplum's cool cousin. It's built on Postgres 14.4, giving it access to newer and more advanced features. You get that familiar Postgres feel with the promise of more modern capabilities and enhancements. In short, it's a balance of what you know and what you'll be excited to discover. Next.
Hey Ed, can I just ask you a quick question? Like, how is this Apache Cloudberry different than the license that you talked about for the old Greenplum stuff?
Dude, it's pretty amazing. The new ecosystem with Apache, it's exciting. It's the Apache 2 license. I'll be diving into that in just a little bit, but so hang on with me. One of the major perks with Cloudberry is its stability. Again, like I mentioned, it's on Postgres 14.4, which is actively supported and regularly updated by the community. This is a big step up from Greenplum's older Postgres 12, which just so happens to have reached its end of life last month. With Cloudberry, you not only get a stable core, but also gain access to newer Postgres features, making it more adaptable and reliable for production environments. Next. Now here's where things get comfortable for you. If you know Postgres, you know Greenplum, Cloudberry is a familiar friend. That pSQL prompt, it's all there. Your existing queries, internal processes, they'll transfer over smoothly without major rewrites. Your application teams, DevOps, DBAs, and dare I say your finance teams, they'll all have something to smile about. Picture moving into a new house, and everything from your old place fits perfectly in the new place. The transition is practically seamless, meaning you can get back to focusing on innovation, not re-education. Next. The foundations of new homes matter. This is why being under the Apache Software Foundation is a big deal. For over 25 years, Apache has been a leader in open source, strong policies, and transparent governance model. Apache's protection ensures that Cloudberry's open source values and lineage remain intact. It's the stability developers trust and credibility that reassures companies looking to invest in open source technologies. Earlier, I referred to ASF as being the gold standard in an open source development, and here's why. Apache, it hosts over 350 top-level projects. It powers much of the internet's infrastructure. Many cornerstone technologies started and continue to thrive at Apache. And you're familiar with these ones: Kafka, Spark, Hadoop, the HTTP server, which started it all, Tomcat, and so much more. Next slide. The Apache way is considered the ultimate example of open source governance. It's used a merit-based system that many other foundations have tried to emulate. One of the cool things about Apache next is that its vendor-neutral approach that prevents any single company from dominating. What had happened with Broadcom is not going to happen here. No company is just going to take this away from the open source community. Major companies like IBM, Microsoft, Google, and Amazon rely heavily on Apache projects. Many companies dominate and donate their projects to Apache for neutral governance. The foundation's strictly licensing and IP practices are trusted globally. I'm happy to say that we have some folks that have been helping us through this Apache process. Our champion, Roman Shaposnik, RVS, has led the way and has been with Greenplum for many years. And so this is actually cool that he's kind of looped back with us here. We have two amazing mentors in Apache, Ken Yao and Willem Jung. The Apache way is just something beautiful. Next. Cloudberry is looking ahead with a roadmap designed to meet enterprises' needs. We're committed to backward compatibility, regular security updates, and developing features that align with real-world analytic demands. This isn't just about keeping up with trends, it's about creating a tool that matures alongside your business, ready for the data challenges of tomorrow. Next. And here's where we invite you to join the Cloudberry journey. Whether you're migrating workloads, contributing code, or simply sharing feedback, your involvement will directly shape the future of open source analytics. It's an opportunity to help write the next chapter in data warehousing from BI to AI in a way that's accessible, collaborative, and most importantly, impactful. The pieces have fallen into place beautifully as I've joined this remarkable team where our collective strengths will create something truly exceptional. And I hope you'll join us on this journey. Next, I'm excited to introduce Louis Magnano and Antonio Petroli. I worked with Louis for many years with Greenplum, where he was an outstanding customer champion, always ensuring that the needs reached engineering teams loud and clear. It's Louis' way. Louis and Antonio remind me of Optimus Prime and Bumblebee, bringing decades of data expertise with innovative thinking. Louis will be presenting their collaborative work next. Please welcome my buddy Louis. Louis, take it away.
Thanks, Ed. I've certainly been referred to as loud. Don't think I've ever been referred to in 35 years as Optimus Prime. So thank you for that intro. So I'm going to actually start off by just kind of introducing myself and Antonio. So both of us come from Greenplum Professional Services. I've also done pre-sales in my life for Greenplum. So we've now gone off and started our own professional services business. We've decided to collaborate on projects involving Cloudberry to try to bring this project forward. So I did see a question, ironically, in the chat. Is anybody running Cloudberry in production? As part of this, I will answer that Antonio and I just actually completed a fairly large project for a Greenplum customer who migrated to Cloudberry and just probably 2 or 3 weeks ago actually did go into production. So we can say, just from us, now I'm sure other customers have, that we don't know about, have used Apache Cloudberry and probably are in some form of production. But at least we can say confidently that we did migrate a fairly large Greenplum customer in the petabyte range to Apache Cloudberry. Antonio actually did a video that we will be posting up that talks about that project as much as we can, obviously. Give you an idea of how we migrated, how we helped the customer migrate, what kinds of, what the use case was that warranted them wanting to go to Cloudberry. So look forward to that, and we'll get that out to you as soon as we can. So next slide, please. So before I just jump in, and I know Jacques put me on the spot and kind of said, I'm going to simplify this all for you. I think they always rely on me to dumb things down, I guess, because I'm not the smartest person in the room ever. But I wanted to kind of just start by defining some foundational pieces, right, that'll make the understanding of Cloudberry a little bit easier. A lot of us that come from the Greenplum background take for granted sometimes some of this, and I know a lot of the audience here is obviously Postgres. So I wanted to kind of take these foundational steps. So what's the first piece of that? I wanted to talk about vertical scalability versus horizontal scalability, right? So when you think about vertical scalability, it means you're upgrading a single machine. You're scaling up, right? So what that means is as your Postgres database today reaches a point where you're maxing out CPU, you're maxing out RAM, or you're maxing out storage, your approach is I have to go buy a larger server, or I can expand my existing server if for example, I'm only maxing out one of those things like RAM. Maybe you could expand just by adding more RAM. Now, that's obviously easier to implement that, but it has physical and cost limitations, right? As you continually scale up, the price of those servers incrementally, go up. You're constantly buying kind of the latest and greatest servers, right? So you think about it from a business standpoint. You think about having to go every year and kind of request your budget. You're constantly requesting this big budget, right? Servers really aren't getting a chance to depreciate in value because you're constantly churning and having to increase server capacity. Contrast that with horizontal scalability, which is best defined as like a scaling out architecture, right? Where when you outgrow one server, your idea is to just add more servers, right? So again, kind of using that budgeting standpoint, I can now kind of just assume, okay, I'm going to just kind of define a fixed budget every year. And let's assume I'm going to expand every year because I know my volume is going to increase. Obviously, we all do this in hopes that adoption of what we're building is great, right? I mean, we all want to be successful. We all want what we build to be used and leveraged. So with that comes, the need to expand. So with horizontal scalability, you're kind of expanding as you scale out. The good news with that is, if you think about it, if you start off with the latest and greatest servers, right, or maybe mid-grade servers, as you scale out, you're introducing those. What was mid-grade last year is kind of lower grade this year, right? Because everything is kind of moving. So those servers are kind of actually cheaper as you're scaling out. Now, eventually, that'll all depreciate, and you'll refresh the whole cluster. But at least initially, while you're building out, the cost is a lot less to go with a horizontal scalability. Okay, so in short, really, horizontal scaling distributes load across many machines, while vertical scaling focuses on making one machine stronger. That's the general concept there. Okay, next slide. The next foundational piece I wanted to talk about, because again, coming from Greenplum, we just assume, kind of everybody knows this term MPP. I wanted to actually define it for you. So what is MPP? Just the computer definition of it. Let's not think about databases right now. So what is the definition of MPP? It means massively parallel processing, and it refers simply to a computing architecture that uses multiple processes or nodes to execute tasks simultaneously. That's kind of the dictionary definition. Now, in an MPP architecture, you really have three fundamental pieces of it. One is referred to as nodes. Okay, so a node, think of a node as an individual server that has its own memory and CPU and potentially storage, depending on your architecture. And then you have this thing called a coordinator. Now, what the coordinator does, if you remember when Jacques spoke, he kind of talked about that single point of entry. The coordinator is that single point of entry, and it manages task allocations across nodes. Regardless of how many nodes you have, you still have that single point of entry. Okay. Now, with that architecture, one very important piece of that architecture is this, what we call the interconnect network, which is how all these distributed systems are tied together. Okay, so next slide. So now that we've kind of spent time on those two foundational pieces, I can really kind of define what is Cloudberry for you. So what is Cloudberry? It's a horizontally scalable MPP database, primarily used for analytics, similar to Greenplum in that regard, as far as use case. So we defined the difference between vertical and horizontally. We defined MPP. That's what Cloudberry is. It's a horizontally scalable MPP database. As been mentioned already, it's based on Postgres 14 and Greenplum 7, right? But Cloudberry was actually forked and has been in development for 7 years. So those of you in the know, Greenplum 7 hasn't been around for 7 years, so it really wasn't necessarily forked from Greenplum 7. It's just from a compatibility standpoint, it's best to think of it as compatible with Greenplum 7. Even though it kind of forked off earlier from Greenplum 7, it was kind of kept in sync with Greenplum 7, even though they've upgraded Postgres beyond what's in Greenplum 7. So again, for my Postgres users, little pictorial here. If you think of Postgres database as a Postgres database running on a single server, in the case of Cloudberry, think of it as many Postgres databases running on all these data nodes, right? So we talked about a node. A node is a server. And you'll notice that there's actually, if you look at the box, right, the data node server, there's actually 6 Postgres databases represented in there. We refer to those as segments, right? So you'll hear this term a lot where in Cloudberry and Greenplum, you'll hear the term segments. Segments is just that logical breakdown of data, segments across these separate nodes. So even though you might only have in this picture, you have 3 data nodes, you actually have, many more segments running across those data nodes. The coordinator node acts as that single point of entry. So think of that again as a Postgres database. So when you're using your tools, and I did see there was a question about tools. I'll talk about that a little bit in the upcoming slide. But your tools will just kind of connect to that coordinator node. It'll look and feel like a single Postgres database to the outside world. What's happening behind the scenes is behind the scenes. Okay, next slide. So now I want to kind of go into who benefits from Cloudberry. One of the things I was most excited about doing this webinar is we actually got to see a lot of the job titles of people that were joining, and I honestly think we have representatives from probably not executive leadership maybe, but we do have data analysts, data engineers, and data scientists a lot on this call. So how do you benefit from Cloudberry? Little bit of a spoiler alert here. So many of these benefits are really performance based, right? If you think about it, time is money, right? So as a data analyst, right, what do you want to do? You want to really, in a self-service way, you want to do data exploration. You want to look at large data sets, figure out, is there anything worthwhile here that I need to be dealing with? If not, get it out of my way, get it out of my life. I don't want to deal with it, right? But you don't want to spend time working with your data engineers, working with all this stuff to get all this data loaded, only to find out that there's nothing in it that you actually care about or need. So data analysts want to be able to iterate on data, do interactive queries very quickly, get insights, do that in a high-speed way. Once the data analyst kind of says, yep, I do need this data, now your data engineers are looking for a way to kind of build these ETL pipelines, which have gotten way more complex over time, and do this massaging of data and manipulation of data very efficiently right inside the database. I did see another question, I think, about Madlib, right? It's the same kind of concept where what you want to do is push the processing to the data, right? Not pull the data to the processing. That was the intent of Madlib when it was originally, built. So the same kind of concepts apply even in data engineering. You want to kind of move that processing as close to the data as possible as your data volumes increase. Okay. Data scientists, right, who would be obviously a user of Madlib, they, especially more now with the advent of a lot more AI and machine learning, they require much more parallel processing to handle the larger volumes. You want to be able to train your data on as much data as possible to avoid, AI hallucinations and things like that. So you want to be able to leverage as much data as possible. So Cloudberry allows you to do that. Now, even though they're last on the slide, ultimately, as a data analyst, a data engineer, and a data scientist, if the following group isn't getting benefits, then we're all doing something wrong, right? So executive leadership and lines of business is the ones that have to benefit the most, right? They're the ones that they're the ones that really will see the benefit of Cloudberry without necessarily using Cloudberry, but they need to make more timely reporting to make really critical decisions more quickly. That's, the world's changing, things need to be done a lot quicker now. So they absolutely will benefit from Cloudberry with the help of the preceding roles, right? Your data analysts, your data engineers, and your data scientists. Okay, next slide, please. So if I kind of got you excited, right, and kind of ready to move to Cloudberry, I want to kind of take you through some of those considerations to moving to Cloudberry. I'm going to go completely out of order in this slide, just because. So I'm going to kind of start with my Greenplum users. The good news here, and I kind of mentioned this in my intro, we do have experience migrating Greenplum to Cloudberry. The customer that the success story that Antonio put together happened to be on Greenplum 6. So their transition from Greenplum 6 to Cloudberry was pretty much equivalent to going from Greenplum 6 to Greenplum 7, right? Either way, you're taking a major, migration. In the case of Greenplum 6 to 7, you went from Postgres 9 to Postgres 12. In the case of Greenplum 6 to Cloudberry, you're going Postgres 9 to Postgres 14. But the biggest kind of impacts, if you will, are the same as when you're transitioning to Greenplum 7. So think of it as, hey, I got to migrate off of 6 eventually. Do I want to go Greenplum 7? Do I want to go Cloudberry? At least right now, right, and this will change over time, but right now, that transition is about the same going from 6 to 7 as it is from going 6 to Cloudberry. Good news is if you're already on Greenplum 7, it's even smoother, right? It's pretty much a seamless migration. And for Greenplum users, it's a minimal learning curve. Now, I don't think we have probably a lot on this call, but non-Greenplum Postgres users, if you're coming from a MySQL, if you're coming from an Oracle, DB2, something like that, there's no magic bullet here. I mean, at the end of the day, SQL is going to have to be changed to be Postgres compatible, things like that. The good news is there is a Cloudberry Bootcamp repo that you can use to kind of spin up Cloudberry very quickly and test out your workloads, figure out what needs to change. Obviously, there's plenty of software out there now that will convert, SQL from one dialect to another. All right, so now, finally, Postgres users. I told you I was going completely out of order. Now, the good news for you, and I think Ed kind of touched on this too, and I think Jacques did as well. Cloudberry is going to feel very familiar to you from an end user SQL perspective, right? If you know PostgreSQL, you're going to be able to write SQL against Cloudberry just fine. A lot of the tools that you use, I think there was a question, from Marshall, any GUI help for DBAs? Things like dbeaver will work just fine going against Cloudberry. Again, because a lot of tools really just connect to a Postgres database. And because Cloudberry is so up to date, right, with Postgres 14, most things are, most tools are compatible with Postgres 14 and will be compatible with Cloudberry. Where it gets a little bit different is when you have tools that are, maybe loading data into the database, things like that, where you want to leverage more of the parallelism. Sometimes there might be more stuff to think about there. But at least a lot of the tools that you're familiar with from a user perspective that you use to, just to write SQL into a database will work with Cloudberry. And if it doesn't, we have the open source community to help things along. And I'm actually working right now with a data modeling tool called DB Schema, and using it with Cloudberry, and was able to, kind of use the Postgres, do some manipulation to the tool, and it works just fine with Cloudberry. Okay. Now, normally when there's good news, there's bad news. There really is no bad news for Postgres users. The only, thing is you do have to develop an understanding of MPP systems. And Amy, it's fine to go to the next slide. So that's kind of what we're going to do now. I mean, a deep dive in 20 minutes, we can't get too deep, but I at least want to get these fundamental kind of concepts on how Cloudberry achieves the parallelism and the MPP. And that really starts with one very fundamental concept that you have to understand, moving from any single instance database to an MPP database. And that's distribution of data, right? So if you think of MPP, if you really think about what is it, how is it achieving what it's trying to achieve, I like to just really dumb it down to its divide and conquer, right? You have a large data set, you have a large, block of data you have to look at. You want to divide that as small as you can to kind of just have as many workers looking at as small a piece of that as possible. So that's kind of the concept of distribution of data. What it's doing is it's taking, in this case, in the simplest case, right, we have an order table. It's taking what would be a very large order table, obviously not on a slide, but a very large order table, and it's taking individual rows and it's deciding where to put that data across your cluster, right, across your nodes. The way it does that is when you define the table, you say how I want to distribute that data. What you want to do is achieve an even distribution as much as possible. So in this example, I could tell just because there happens to be two arrows coming from customer ID 12 that more than likely this table was distributed by customer ID. Okay. So that's one of the first fundamental things. Now, honestly, many customers of Greenplum that we worked with stopped right here. This was enough for them, right? They were able to go from Postgres to, Cloudberry or Greenplum, and just by distributing data, they were able to achieve the performance that they needed to achieve. So in some cases, this is enough. But let's talk about what this means as we distribute data. So next slide, please, Amy. So with the distribution of data comes this idea that data has to move, right? There's no way around it. If you're going to have data that's spread across your cluster, you have to have movement of data. That's why, if you remember in the architecture, I talked about that interconnect, right? That that high-speed interconnect, that network that's tying all this. That's why that's such a critical piece of an MPP system, because ultimately data has to move within the cluster in order to satisfy queries. Now, the terminology that we use for that is motion operators, right? So there's really three primary motion operators you'll see in Cloudberry. One is a gather motion, right? You can't avoid that motion. What that motion is basically saying is that the coordinator has to gather all the results from the data nodes in order to return the result to, the end user. So a gather motion is just, something you can't avoid. Then there's these other motions that you'll see primarily when you're joining, well, only when you're joining multiple tables. You'll either see what's called a broadcast motion or a redistribute motion. There are really two different ways of ensuring that as you join data, that the data that needs to be joined is co-located on a single, data node. So the way that happens is with broadcast motion, the optimizer simply says, take this table and just all the rows, just broadcast it to all the nodes, right? So now you have a copy of that table essentially across the entire cluster to satisfy that join. Redistribute motion is a little bit smarter, and it just kind of says, okay, I know what I'm joining, and I just need to get some small subset of that table and get that copied over. So that's what a redistribute motion is. We get into a lot more details. You can kind of begin to guess, right, that the optimizer becomes critical in making that correct determination. And things like statistics and analyze come very important, because you don't want to broadcast a very, very large table, for example. Okay, so next slide. So just again, to kind of help you with that familiarity, I'm sure a lot of you have looked at explain plans. So let's just look at a real simple example just to show you that, there's nothing mysterious here. So a real simple Postgres explain of a simple select star from a test table. Test table has 10,000 rows. I think it's 10,000. Yeah, it's 10,000 in this example. So in a Postgres explain, what you would see is a sequential scan on test. You see that the rows equals 10,000. Running the same exact query in Cloudberry, again, in this example, I have actually 2 servers and 4 segments, right? If you see there, server 1, segment 1, server 1, segment 2, server 2. So there's actually 4 segments. So in this case, you'll see that the sequential scan is still there. There's nothing mysterious. You'll notice it's kind of indented a little bit, because what it's saying is the sequential scan is happening on the data nodes, right? So that's why it says rows equals 2,500, because in this example, we're assuming that everything is evenly distributed, or in this case, it is evenly distributed. So each sequential scan from the data nodes is taking in 2,500 rows. And there you have your gather motion, right? We talked about that. That's the one you can't eliminate. So the gather motion, what the 4:1 is saying, the gather motion is taking the results of 4 segments and bringing that together in one single result set. Next slide. Just to take you through a little bit more complex example, this one is a join. Now, I don't have the query here. I don't have the data model here or anything, but I can pretty much tell you that in this example, T1 is probably like a small dimension table. T2 is probably like a very large fact table, right? And you're just doing a simple equal join of these 2 tables, right? P key T2, P key to T1, P key. In Postgres, that's implemented as a hash join, sequential scan, build the hash, do the hash join. In Cloudberry, you have to have this motion, right? So in this case, the reason why I'm assuming kind of the size of T1 is small is because Cloudberry chose a broadcast motion, right? So what happens is there's a sequential scan of the small T1 database. The results of that are broadcast across all the data nodes, and then you do your hash join. So you still see the hash join, you still see the sequential scan. If there was indexes, you would still see in the index lookup. So everything's very familiar to you as a Postgres user, except you're going to see these motion operators in your explain plan, and you kind of have to understand, what that is. And that's what I mean when I kind of said it wasn't bad news, but you do have to understand MPP and kind of what it's doing for you. Okay, next slide, please. So we talked about distribution, right? We talked about motion. As I mentioned, a lot of times distribution is enough. A lot of times, especially if you just kind of like, our Postgres stuff is performing, okay. We just want to kind of speed things up a little bit, or we know we're going to be getting a lot more volume. We need to kind of think about scaling out a little bit. Distribution alone can get you there. But let's talk about, again, that taking that analogy of divide and conquer a little further, right? Once you kind of spread your data out, right, that data is going to continue to grow. And eventually within even a single node, you might have a massive amount of data. So now how do you divide up further, right? You can't keep going to the well and keep expanding forever. I mean, you can, but, that can get costly. So you got to think about other ways of dividing your data. So partitioning is another one, and this is in Postgres as well. But partitioning is very critical as your data, needs expand as a way of dividing data within a data node, right? So once you kind of divided the data across, now you want to divide the data within. That's where partitioning comes in, right? So if you leverage partitioning and users are querying only a subset of that data, then they could just get a slice of that data. So in this case, there's 3 partitions, P1, P2, P3. And in theory, if you do the query, where you can get what's called partition elimination, you might only have to look at the P1, the purplish color, and it won't even look at P2 and P3. That's kind of what partitioning buys you. Another way to divide data in Cloudberry is this concept of orientation, right? So standard databases have, the data is just stored as a row on disk, right? So if you have 100 columns, it's just, one big row of data. Another way of dividing the data is to decide that my use cases, it makes more sense to store in a columnar way, right? So columnar takes each column and stores each column individually. That works great for analytic type queries where you're doing a lot of slicing and dicing, where you're probably not looking at 100 columns in your, let's say, dimension table, but you're slicing and dicing on 3 or 4 columns, right? Columnar works great in that context, and again, helps divide that data. Additional performance features are compression, right? So again, once you finish your dividing, you may want to reduce how much data things actually have to scan off disk. We saw that sequential scan, right, in our explain plan. Each IO, the more rows or the more columns you can get out of a single IO, your performance is going to be enhanced, with the offset of obviously CPU to uncompressed. But in reducing IO is usually a good bet in analytic type databases. Again, good news for those Postgres users. And the reason this is kind of a little lower on the list is because you might not jump to using indexes right off the bat in Cloudberry. It's probably going to be your 3rd or 4th level of optimization. But the good news is Cloudberry supports all the index types that are supported in Postgres, btree, bitmap, gist, gin. If you're using PG Vector, the PG Vector indexes are also in Cloudberry. Now, with all these performance features and with the advent of understanding motion and all that stuff, there is a need for an MPP big data query optimizer that's built into Cloudberry. Again, the good news here is that the Postgres optimizer and planner has adopted a lot of what it needs to adopt. So there's actually a lot now that Cloudberry will just say, you know what, Postgres, you got this. You know what, we don't need to use our query optimizer. Go ahead and handle it. You as a user don't have to worry about that, right? The optimizer will decide which is a better alternative, using the big data query optimizer or the Postgres optimizer, and it will decide that on its own. Again, with the advent of MPP, you do want to utilize parallel utilities. So even though, again, from a comfort standpoint, things like copy are there, things like PG dump, PG restore are absolutely there, but they're not fully parallel. They're not fully leveraging the parallelism of the MPP architecture. So Cloudberry introduces additional utilities that take on that responsibility. So in the case of loading, it's GPF disk, GP load. In the case of backup and restore, we have, as part of Apache, the GP backup and the GP restore. Next slide. All right. Now, as much as we would love you to store everything you have in Cloudberry, clearly that's not the way the world is operating. So this database interoperability is a very important piece. Again, good news for Postgres users and Greenplum 7 users. Cloudberry does have full support of foreign data wrappers, and bundled into the standard package are things like Postgres FDW, File FDW, and PXF FDW. We also have Cloudberry PXF. PXF stands for Platform Extension Framework. This actually came about by Pivotal when Apache Hawk was being developed. PXF was its kind of interoperability functionality. It gave us connectivity to Hadoop and other relational databases, like any relational database that can support JDBC. At the time, cloud storage was very important. People wanted to access S3, blob stores, Google Cloud, and different file formats became popular, right? Avro and Parquet. So PXF kind of incorporates that interoperability. Next slide. So normally, right, when when infrastructure vendors are talking about database products, here's where they tell you, okay, and now you can buy this huge appliance that's only going to cost you $4 million to run all this. Certainly not the case here. What is the case here is pretty much anywhere you can install an RPM, you can run Cloudberry. So the example success story that Antonio and I worked on happened to be cloud, happened to be AWS. But you'll see when you kind of look at that video, you'll see that there was, at least the way we separated the duty there, it really could have been anything, right? So you can run on-prem, you can run on-prem servers, on-prem virtualized, you can run in the cloud, you can run containerized. That's what our bootcamp is written in. So again, anywhere you can install an RPM, you're good to go. So I'm going to now hand it off, I think, back to Jacques, who will take you through kind of how you can continue the journey with us. And I'm going to stay on, during Q&A and help out with any questions that I can help answer. Take it away,
Perfect.
Jacques.
So thank you, Louis, and thank you, Ed. I'm looking at the names here in the audience and thinking about what a passionate community we've always had for massively parallel Postgres, and I'm personally super excited to see that passion continue into this next chapter with Apache Cloudberry. There's a bunch of questions out there. We're getting close to time, so we'll try and be a little bit respectful of time. But one of the questions out there was, like, how do I get commercial support? How do I get started? Well, one call to action here on this page is a QR code where you can send an email straight to cloudberry@infuse.io. Around the world, there are organizations who are offering support of open source Apache Cloudberry, and that is both in the form of consulting services as well as software support for commercial packaging. And so reach out to cloudberry@infuse.io, and we'll be happy to get on call and talk to you a little bit more. If you go to the next slide, there's been a lot of great questions. And so if you're looking for immediate resources in order to get started with Cloudberry, here is another QR code that will take you to the official cloudberry.apache.org site. On that site, there are a lot of documents and videos that you can read, but also if you're looking for more real-time engagement from the community, we have a Slack channel. Clearly, there's our GitHub repo. Please come reach out, join those discussions. We want to make sure that this community continues to grow and thrive. And with that, I'll go to the next and final slide, where I'll actually throw out a couple of these questions here just for the team. And we do have a large team behind the scenes here answering questions. So if you've seen them in the chat, hopefully those answers sufficed, and if not, please again engage us so that we can continue having the conversation. But for example, how do we get support for Cloudberry? Reach out to cloudberry@infuse.ai. Another one I saw, you mentioned artificial intelligence. Of course, we would be remiss if we didn't also mention AI because everybody mentions AI. But to that point, is there PG vector support? Yes, through Infuse, we are offering PG vector support, and it is one of the packages that it's compiled with. This one is a good one that I'd like to just throw out to the team here. What are the biggest challenges migrating from Greenplum to Cloudberry? Louis, do you want to take that one?
Yeah, and I saw Greg actually put something there as well. So I think, as Greg said, schema wise, there's really no challenges, right? I mean, DDL is gonna migrate just fine. Data wise, it's the same as anything else, right? If you have a massive amount of data, you have to move a massive amount of data. There's no way around that. But there is tools, whether it be as simple as backup and restore, which you can parallelize the backup and restore. If you don't have, external storage to store data, there is ways of copying data, just streaming across a network. So I correct me if I'm wrong. I don't think it's fully in the product yet, but it is contributed by the community and very accessible. I'm talking about
That's
CB.
exactly, that's the cool thing about these open source projects, right? Is that people are able to contribute, and so we actually have some pretty cool migration options in the community developed and part of it, right? And so everything doesn't come into Apache. There's processes that kind of are in place, but cool stuff is actually coming, and it's cool to kind of see it just expand.
Right, and it, when you look at Antonio's video, if we didn't have the community behind us, we wouldn't have been as successful as we were migrating the customer we had to migrate. I mean, we needed the community. We needed Ed. We needed Ed gave us, RPMs that we needed that really simplified, because I probably grossly underestimated what it would have cost otherwise.
Right.
So we got the help we needed from the community, and that's what's nice about obviously being part of this open source community. I mean, just the amount of help we can get, and even GP backup and restore. I don't remember who the person was, but somebody actually contributed a fix to that pretty much right when we needed it. It just happened to coincide for when we needed it, and it help the customer actually migrate. So Antonio and I actually weren't even involved in the data migration piece. The customer was able to leverage what they've been doing for years with Greenplum, and they were able to migrate their own data. So they didn't need our services for that. We did, other pieces of the project.
That's fantastic. So we're right at time, and there are other questions. So I will commit to make sure these questions are pasted into the Slack channel so that everyone can see them. One last question that I'm going to turn back over to Lindsay, but there was a question that said, thanks for recording the session. How can we get the recording and also evaluate Cloudberry? I think the second half is covered, but the first half is over to you.
Hi, Al. Yes, so I'm going to go ahead and download this recording as soon as we're done. I'm going to zhuzh it a little bit, and then it should be live on the exact same landing page that you registered. So we will send a follow-up email saying, here's the recording with the link. And with that, y'all, that was fantastic. You moved through a whole lot of information very quickly. And I really, really appreciate the time and effort and thought put into sort of distilling this pretty complex but very useful thing. I also want to say thank you to our guests and everyone who spent a little bit of your day with us. So regardless of where you are, whether it's morning, afternoon, or evening, I hope you have a great rest of your day. And I hope to see you on future Postgres World webinars. So cheers. Thank you.
Thank you all.
Thank you.
See you
Thank
again.
you. Take care.